think almost you are going to spend some 3 years only to learn this particular thing. So in a very less time interval, I'm trying to conclude the most of the concept here. And again, similar like a diode, we learned diode, the working of diode. And when you go to numericals, were totally different. No? The same thing here. The transistor theory is little bit okay, fine, everything fine. But when you're doing numericals, no, again applying KCL, KVL, and maximum either theoretical or numericals. So numericals are not much related to the basic theories. Just a small basic conclusion followed by reverse by, that is enough. Again applying the Ohm's law, KCL, KVL, we are going to conclude here. This is what happens in the transistor circuit. What all syllabus we have left over after this is like uh, the logic gates, then again the special purpose diodes like photodiode, solar cell. Of course, they need 1 hour. Solar cell 1 hour, photodiode 1 hour, LED 1 hour, or one class. 2 hours we can wind up 3. Logic gates we need 3 hours. Transistor around 3 hours. Today 2 hours I'll get it. Then tomorrow I'm thinking I'll get 2 hours. Then on Sunday. With this, I think we can manage our syllabus. If you learn now, what happened? The revision little bit easier. Second time it'll be easier. So if you postpone everything for the revision, no, not possible. Because I think if you see total extra syllabus, they're given 1 week revision. It will come in the month of, for you, this in the month of February. Only 1 week. Again, not possible. So better we'll wind up everything now only. Let's not keep anything pending. Okay, I'll begin with this. These are the basically shapes, like if you see the transistor, these are the shapes. There'll be that one, means how much you can just hold this particular thing. So it'll be of what can be, sir, like it dimensions, everything. The legs will be of length around say 1 centimeter. This one, this will be of 0.45 centimeter. That one you can see from legs that this will be that one. Okay, this will be a little bit bigger. This is called a power transistor. These are very small, tinier, like buttons in fabric. Buttons will be there, no, small of that particular shape. So these are some metal, where metal you can see to dissipate heat. Where plastics are there, so they will open where low power transistor, where you can see metal, no, they are high power transistor. This is completely a power transistor to dissipate heat generated in the diode or the semiconductor material. For that purpose, this called like this particular shield is brought here. So what will do, it will drag heat from the transistor, will give it to surroundings. So they may test you with diagram like this also. They may give physical diagram, which is a diode, which is a transistor, which is LED. So because all these are based on lab, that's why I just brought this diagrams. It's a 3-terminal device. I'll keep on write the characteristics. So it's a transistor. So it contains three regions. It is made up of 3 regions. Emitter region, so it's a semiconductor material only. I'll take semiconductor in molten state. Then I will add pentavalent impurity atom to this region. I'll add more pentavalent impurity. It will be heavily doped here. So this region will become emitter. So since I added pentavalent impurity atom, this will become N-type semiconductor. This is called like a base. Here I have had trivalent impurity atom and their number will be less. This is lightly doped. Then this is a collector. This region is called as collector. And this is moderately doped here. So what are the doping levels? This is heavily. This is lightly and this is moderately doped. This terminal, this is for connection, no? Like you have seen, I have to connect in circuit. So these are the three leads are able to see. Leads we call, what are these? These are called, okay, technically we'll call it lead. We don't say rod. Leads means one which you are going to use for connection. Like if you take the bulb, so where the leads will be like this, no? You'll give some connection for this. Or if you take switch, this will be switch. So these are called like leads here. To to connect transistor with other elements, I need know. So these are called leads. So this called like a collector lead. This called like a base terminal, or you can call also terminal leads or terminals. And this is the emitter. So like this, what happened? We have three terminals. That one. So what is it? There's a transistor. It's a three-terminal device. It's a three-terminal device. Consists of, now what is the name for the terminals? Emitter, base, and collector. And it contains three regions, the same emitter, base, collector. Among that, I think I shown here only. Now, what about the size? This is large in size. I think rather than sentence, let me dump everything in this one. This is thin. This is moderate in size. So how the three regions, the dopings, emitter is heavily doped, base is lightly doped, collector is moderately doped. And what about the size? Collector is large in size, base is very thin and lightly doped, emitter is heavily doped and moderate in size. This collector is moderately doped and large in size. Why they are done? Large in size, as collector is large in size, it has to dissipate more amount of heat. Collector is large in size as it has to handle large amount of heat in that region, so therefore it is made large in size here. Okay, these are the doping levels. Now what all I do, connections will be like this. So are you seeing this junction? So we'll call this junction as, this is base emitter junction, this is called as collector base junction. The name emitter base junction, or you can call it as base emitter junction. There are two junctions are there. So we know junction, PN junction it is. So we can forward bias, reverse bias. So based on that bias across junction, it can be utilized for various operations. Various operations, there are only two operations are there. One, amplifier. Transistor, what are the uses of transistor? Transistor can be used as an amplifier. Uses of transistor. As an amplifier or electronic switch, on off switch. So like we have physical switches. Suppose in your home now you switch on and off, no, the bulb or the fan. It's a mechanical switch, or better called electromechanical switch. Electromechanical switch. Purely electronic switch. A good example, I think in television, no, we switch off the television. How? Nowadays with remote, no. So what's going on there? The transistor will be there, that one. It will on and off. You can make it on and off. Electronic circuits can be switched on and off using the transistor. So therefore, electronic switch, what we call. So we are going to discuss both the things, both as an amplifier as well as the electronic switch here. Just I'll attend one call. Okay, sorry for disturbance. My son's teacher, she called. How is studying? Is doing homework or not? Is writing exams or not? Okay, no. A use of transistor as an amplifier, electronic switch. So if I want to use as an amplifier, no transistor to be used as an amplifier, it must be operated in active region. This active region. So I'm putting like this. What do you mean by active region? Transistor will be an active region. What is mean by active region now? Where base emitter junction will be forward biased and collector base junction. Shall I write JCB, collector base junction, the symbols, and collector base junction should be reverse bias. FB means forward bias, RB means reverse bias. Please try to understand the symbols here. So when you can say transistor, so amplifier, it must be operated in active region. What is amplifier? I think when in college I used to wear some amplifier, no mic, and that one box used to be there. I used to wear that one. So what is that? What it does? Without that, my voice very less, no. Because of amplifier, most of the class was able to hear me. So what it does? It will increase the amplitude of signal. This was the amplifier. So the transistor to be used as an amplifier. So it must be operated in active region. What is active region? There are two junctions are there. The type of bias what you give across that, based on that it will become an amplifier, it will be an active region. So the what bias you give across the junctions, no. So when you base emitter junction, this is forward bias, this is reverse bias, no. Based on that, what when we have to call that as active region. Now similarly, if you want to use in as electronic switch, for switch, it must be operated in cutoff and saturation region. Okay, later on in the numericals, I tell you what do you mean by cutoff. Cutoff saturation region means saturation means both the junctions are forward bias. Okay, or cutoff in the sense like a collector current will be zero. Saturation means collector current, this current through this collector should be maximum. So I'll come to later on. Let me focus on amplifier first here. So there's a meaning of cutoff and saturation. Later on in the theory explanation, I'll stress on these things. Now let's come for amplifier. What is the basically amplifier means? What is the definition of the amplifier? So if you take the block diagram, if you give small AC signal, what is the time period T? Being, it will amplify it. It will not change frequency. What it will do? It will only increase the amplitude of signal. You can see amplifier. This is bigger. The time period remains same. Only thing is this is the output. So earlier it was around, say, like a what is V in? This was of magnitude 10 millivolt. Now it has become 5 volt. So from milli it has become 5. Who does amplifier? So what it does, shall I say, it has increased the strength of signal, energy of signal. How do that amplify? It will convert, it will utilize the DC source. Here I'll be connecting this to a DC source. I'll connecting it to a DC source here. A cell to a cell, I'm connecting it. And what is the DC source? No, what is amplifier? Converts DC energy to AC energy. What about rectifier? Converts AC energy to DC energy. But don't say reverse operation. This is purely we are using for some other thing. No, without a mic and amplifier, if I speak, hardly anybody can hear me, especially my voice. Then if I bring mic and amplifier, then what that amplifier does means what is that system? So here we have a mic. Okay, there's a mic, there's a person. He will speak, no? So what all he speaks, there's a sound wave will come. These sound waves, what will happen, will go and strike mic. So there the mic, what happen, the mechanical sound wave will make the layers to undergo displacement. Due to change in resistance, electric signal will be generated. That electric signal will be given to the amplifier. So this electrical signal will be very weak. AC signal it will be of order few millivolt. When I give this to the amplifier it will increase the amplitude of signal. It will make it large, 5 volt, 10 volt. This will be given to loudspeaker. Now loudspeaker there open the layer will vibrate. So we'll get a sound. Sir, how come a layer vibrate sound? You just take pen, paper, something. You can see that. What I did, I produce sound signal. How I produce sound signal? By just making the papers to vibrate. Are you trying to see the? Are you getting some sound? I am not producing. My lips are tight. Just by waving the book, what happened? I'm getting a sound. So like that here, inside the loudspeaker will be having a layer. As that layer vibrates with the frequency, it will produce sound signal. The same sound signal what the person was talking. Only thing is what happened? The amplitude. This was of low amplitude. Now this will produce a sound signal of higher amplitude. We'll get a sound signal of higher amplitude. Loud signal. So that's why what we call loudspeaker, we'll call this one, no? It will not speak. It will just produce electrical signal to AC signal. And what is the mic? Converts mechanical sound wave to AC signal. What about loudspeaker? Converts electrical AC signal to mechanical sound wave. That's called what we say woofer, no? As it vibrates, we'll get a mechanical sound wave here. I think a loudspeaker, mechanical loud sound wave of large amplitude. So everyone is able to hear, is going to able to hear that one. So inside this amplifier, who is the main component? The transistor. Okay, got this? That's a basic idea. So who is there? So main component here will be there. This is a transistor. So he is the main component of this one, this amplifier circuit. Got this? Now the transistor to be used as amplifier, what I should do? I should make this as, okay, this right. I should use that transistor to be used as amplifier. What happened? I should operate in active region. To operate in active region, what I should do? I should bring a bias. Okay, how to forward reverse bias a diode? I need a cell. Shall we go for constructing a circuit now? Constructing a circuit. So it's a three terminals are there. So I should base emitter junction should be forward bias, collector base junction should be reverse. For that, I'll design a circuit here. Okay, this is the initial background. No, if it were amplifier, sir, I didn't understood. Let's assume that if I have a money amplifier, I'm trying to build up the idea. If there's a money amplifier, okay, suppose say you have constructed money amplifier, you give 1 rupee for it. Then, if it makes it 100 rupees, good, no? Especially if I get, I'll stop working. For 1 rupee, what happen? You give it to this. If you make it 100 rupees, then good, no? Tell me what is the gain? So you say gain, no? How much you gained? You spent 1 rupee, but you got 100 rupees. So tell me what you get. Don't say gain means 100 minus 1, 19 rupees gain. So how you define gain? 100 by 1. 100 is the gain. How much you gain? 100. So don't say profit. Profit is 99. Are you getting the idea? Gain and profit. Profit is 99 rupees. Profit is 99. How much you gained? Finally, I gained 100. I gave 1 rupee. I gained finally 100 rupees. So therefore, gain means output by input. Similarly, here we'll define voltage gain. How much I gained? Voltage gain. So this should be output voltage by input voltage. So symbol what we use for gain is AV, voltage gain. A capital A is the symbol for voltage gain. This should be V out by V in, or delta V naught by delta V in. So what is the gain? 5 volt by 10 millivolt. 5 by 10 to the power of 5000 is a gain. It's a good amplifier. So therefore, how the amplifier is justified, whether it's a good or bad, if the gain is more. If the gain is more means, even if a person talks with a very less strength, with a less amplitude, if it produces large loud signal, then you can say good amplifier. If a person speaks loudly but hardly you can hear, the gain is poor. The amplifier is not good. So how do we justify that amplifier is good or bad? By its gain. Now are you getting the idea of gain? Output by input, 100 by 1. Profit is 99. So don't leave that mathematics here. We are not bothered profit here. We are bothered about the gain. Like this, we define voltage gain. Output voltage by input. Similarly, current gain, output current by input current. That will become current gain. So here, these are the terms. I'll be using this one. Delta high O by delta N. So this is called like a current gain. So what is amplifier? The amplifier is it good or bad? On what basis we say? On basis of gain. Since we are using this for audio range, it's called as the audio amplifier, because what it will amplify? It will amplify only the signals of audio range, no? Because the person speaks, what signals will come? When a person speaks, what signals will come? Audio signals. When a person speaks, what pen, you'll get audio signal, no? So what it will amplify? Audio signal. Then if you use the mobile, then if amplifier amplifies the mobile signals, then it will become microwave signals it is. So like that, depending upon the range of the frequency, so the amplifier is given name audio frequency, radio frequency amplifier, high frequency amplifier, microwave frequency amplifier. Since our discussion is only for audio signals, so I'll call this as audio amplifier. Let's confine to our syllabus here, audio amplifier. Okay, sometimes you see this. Audio amplifier. Okay, what is our entire discussion? We have to finally design amplifiers. For that, I'm using transistor. And now let's get into the transistor here. For transistor to be used as an amplifier, what is the basic necessity condition? It should be an active region. To bring it in active region, forward bias junction, base emitter forward bias, collector bias junction, reverse bias. Okay, how to forward bias, reverse bias? Let's go for circuit here.